Good afternoon, everybody, and welcome to the International Scientific Online Conference on Algebraic and Geometric Method of Analysis. My name is Hakim Munim, and I'm honored to serve as the chairman of this session. Dr. Sako will present his last work on solution of n-body harmonic oscillator and the Calogero model using some matrix model. Without further ado, please join me to welcome Dr. Sako. The floor is yours.
Thank you. Thank you, Professor Monami, for introducing me. First of all, it's an honor to be part of this conference. When I received the invitation email, I was surprised that this conference would take place in the current situation in Ukraine. So I'm proud of the organizers and everyone else who is supporting this conference. I know you are having a hard time because of the Russian aggression, but remember that many people around the world are on Ukraine's side, and I hope that you will be able to get through this difficult time. Okay, it's time to go start. And what I want to talk today is the relationship between matrix model and the harmonic oscillator system or Calogero model. It's based on the joint work with Harold Grosse from Vienna University and Reimer from Münster University, and Kanomata, he's my student from Tokyo University of Science. Okay. So this is the talk plan. I will start with historical background, and next I will discuss the origin of the matrix model from the quantum field theory on non-commutative space. And next I will show that the harmonic oscillator system and the Calogero model are described from the kind of matrix model phi force model. And I will comment on some Virasoro algebra and summarize. Okay, let me explain a little about the historical background of matrix model. In 90s, matrix model was studied in terms of two-dimensional quantum gravity. Among them, one that is closest to the content of this talk is Kontsevich model. This model was proposed to solve the Witten conjecture. So this the model is given by this, and that is described by using a Hermitian matrix phi and some diagonal matrix lambda and phi cubic potential. The model we will share today is a matrix model in which the cubic phi replaced by phi force. Okay. And I'm sorry. In 2000s, different motivation led to the study of matrix model. Matrix model as a quantum field theory on non-commutative space. In particular, Harold Gross and Harold Steinacker shows that the phi cubic scalar model is renormalizable. That is basically equivalent to the Kontsevich model. And in addition, Gross and Ruckenhauer shows that the phi force model is also renormalizable. Okay. So let me explain with a simple example why the quantum field theory on non-commutative space is given as a matrix model. As the simplest non-commutative space, let's consider the Moyer plane. Moyer plane is basically the Euclidean space, but the coordinate is non-commutative. So this theta is a non-commutativity parameter, and x1 and x2 is the coordinate of the R2. And if you use the complex coordinates z equal x1 plus ix2, then the commutator is replaced by this guy. Or if you want to create some representation like a Fock space, we can introduce an annihilation operator or creation operator like this, and it satisfies the famous Heisenberg algebra. And for example, if we construct the Fock representation, we choose a base vacuum vector is defined by using zero eigenvector of the annihilation operator, and Keten is defined by this expression. And this vector is eigenvector of the number operator defined by this. And using the dual basis satisfied in this relation, then we express any field by using such kind of matrix. Especially if we consider the real scalar field phi, then the phi mn is given as a Hermitian matrix. This is the story phi matrix model is considered as a quantum field theory. Okay. Now that everything is ready, it's time to get down to the main issue of today. The S is called the action. Phi is the n by n Hermitian matrix. And E is the diagonal matrix. The eigenvalue is E1, it's blah, blah, blah. And eta is a real positive constant. And this Z is a partition function that is integration over the Hamilton matrix space of E minus S. And here is the main theorem of this talk. And let's introduce function psi by Z multiplied by van der Waals determinant and the exponent function. Then this psi satisfies the Schrödinger equation with zero energy. The Hamiltonian is here. That is exactly an n-body harmonic oscillator system. So two completely unrelated physical systems are now connected. So let's see the proof. As it's not a good prospect to proceed with the calculation with diagonal E, so we use more general Hermitian matrix H. If we diagonalize H, then it's obtain this E. So we use this action S. E is replaced by H, but the partition function is not changed by this change of variables. So we calculate by using this partition function using this H. So let's consider the Schwinger-Dyson equation. Schwinger-Dyson equation is some kind of Stokes theorem like here. The integration of total derivative equals 0. This is rewritten by using this. Here, HKI is element of this H, and this bracket means defined by this O is observable, so it means phi ij, phi jk is observable, and this bracket is defined by this integration. And next, we consider the derivative of hij, then h is here. So the derivative of in hij of this term is given by this. So we get the vacuum expectation value of this guy is obtained by this derivative, by derivations. Similarly, second differentiation in Hij, HMN is also given here. So we substitute these terms into this equation. So we get this differential equation. Okay. And we rewrite the equation in terms of, using change of variables. And then Laplacian is rewritten by, note that Z only depend only on EI. So the other variable we don't concern. So Laplacian is rewritten by this, and this differential operator is written by here. So this differential equation is rewritten by this in this way. Okay, we call this differential second order differential equation LSD. Okay. The name sounds like a drug, but it's not mean LSD drug. This name is this name mean Laplacian-like operator derived from Schwinger-Dyson equation. Okay. And this differential operator LSD here is diagonalize in certain function, like using some kind of gauge transformation. Then we get the diagonalized operator. This is exactly the Hamiltonian of n-body harmonic oscillator system. Okay, so as it's follow from this lemma that the partition function Z can be similar gauge transformed to give the solution of the Schrödinger equation of n-body harmonic oscillator system. So the main theorem is thus proved. Okay. So next, using Ericsson-Zuber integration, the partition function can be computed a little further, and the result is this function. Thus, the wave function size also can be also written in this way. So consider the simplest case where the matrix size n equal 1. And then the Schrödinger equation becomes a Weber equation. So, and if n equal 1 case, this function is written by using modified basic function of second kind. So in fact, it can be verified that this function is a solution of this Weber equation. Okay. So far, we have seen that such a matrix model of the Hamiltonian matrix, this is the Hamiltonian matrix, correspond to a harmonic oscillator system. So it is natural to wonder what would happen if it were an orthogonal matrix instead of Hermitian matrix. The result is shown in the next slide. Although some complicated calculations have to be done, the only difference in the final result is in terms of this red marked in red, these guys. So this Hamiltonian is exactly the Calogero model's Hamiltonian, which is generalization of harmonic oscillator system, and as similar to the harmonic oscillator system, it is a quantum integrable system. Okay. So this quantum integrable system lead to representation of Virasoro algebra reflecting their nature. We shall see that at the end of my talk. For simplicity, we introduce the variable y. In that variable, the Hamiltonian of the harmonic oscillator is rewritten in this way. And if we use creation operator and annihilation operator, then the Hamiltonian is written in this way. So we introduce the Virasol generator as this way. So of course this satisfies the Virasol algebra, this commutation relation. So in addition, L0 is differ only by the constant from the Hamiltonian. So in the other way, the Hamiltonian satisfy this commutation relation. So by applying the gauge transformation described earlier to this equation, we obtain the additional infinite number of differential equations that the partition function must be satisfied. So the same theorem is obtained for real symmetric matrix case. Okay. So now I summarize the content of my talk. The harmonic oscillator system and Calogero model have long been known as quantum solvable system, integrable system. It is known, and the Virasol algebra was also known, and it's related by using because of the Hamiltonian is given by this bracket using creation operator and annihilation operator. So we discover that the zero energy solution of Schrödinger equation for harmonic oscillator system and the Calogero model corresponding to partition function in the matrix model by a gauge transformation like that. So the matrix model is also quantum field theory in non-commutative space. So the two different physical system is connected by using this some kind of gauge transformation. Perhaps this also means that new solution to this Schrödinger equation has been found. And from Virasol algebra, it was also found that this partition function also contains beautiful structure. Okay, this is conclude my talk. Thank you very much for your kind attention. Thank you.
Thank you very much, Dr. Sako.